Dear ladies and gentlemen, this is the day for the special lecture here at the Budapest University on Technology and Economics from a special lecturer. But before I introduce our lecturer, let me say some words in Hungarian first. Hölgyeim és uraim, köszönjük szépen, hogy eljöttek a ma esti alkalomra. Egy különleges előadásnak lehetnek a részesei, amit dr. Jürgen Steinberger fog tartani. Ő a Knorr-Bremse haszongépjármű üzletágának a korábbi egyik top menedzsere, a Management Boardnak a korábbi tagja, akinek kiemelkedő szakmai szerepe van abban, hogy autonóm járművek vannak, hogy autonóm járműirányítási rendszerekről és vezetéstámogató rendszerekről beszélünk, vagy illetve fékrendszerekről beszélünk. És neki van egy sajátos és számunkra nagyon kedves missziója, hogy itt az egyetemen részben elvállalta ezt a mai esti előadást, illetve a mérnök, illetve nem mérnök hallgatóink számára pedig tantárgyi kurzus keretén belül is átadja azt az ismeretanyagot, ami a mérnöki és az üzleti tudás összekapcsolásáról, szinergikus hatásainak a kihasználásáról szól. Úgyhogy ez lesz ma este a fő attrakciónk, hogy Steinberger úrnak az előadását fogjuk meghallgatni. És akkor átváltuk angolra. Ladies and gentlemen, it's my pleasure to introduce Dr. Jürgen Steinberger, the former member of the Management Board of the Knorr-Bremse Commercial Vehicle System Division. He has a special role in our industry in advancement in field of the automated driving systems, in the automated driving assistance systems and the braking systems. And he has a special mission at Budapest University of Technology and Economics that he has now a lecture, a special lecture about this topic. And he gives lectures in forms of courses for engineering and non-engineering students to teach and train them about the synergies between the engineering and the business processes. So my name is Ferenc Mészáros. I am Vice Dean for the education at the Faculty of Transportation Engineering and Vehicle Engineering here at Budapest University Technology and Economics. And I kindly ask you to welcome Dr. Steinberger. The floor is yours.
So, thank you very much. I have it here. So does everybody hear me? This is the biggest audience I have had so far on the Technical University, so thank you for coming. As you said, my name is Jürgen Steinberger. I'm 54 years old. I'm German. I'm born and raised in Munich. I studied at the Technical University Munich. Actually, I'm a physicist, so I'm not born and raised as a manager. I'm a physicist. I got my PhD in engineering. And then I went to Knorr-Bremse and changed from the classical scientific career to a management career. And had different positions at Knorr-Bremse, different business units I was leading. And the last 9 years I was member of the executive board of the SFN, the European division, and the last 3 years I was leading this board. The reason I decided to have the lectures here at the Technical University are two or three. So Knorr-Bremse has a very big R&D center here in Budapest, and we get a lot of good engineers from the Technical University. And that alone is motivation enough to have lectures here in order to build this bridge between the university and Knorr-Bremse. At the same time, and I just talked to your rector, at the same time I find out that you guys are extremely good educated on your scientific base, but you sometimes lack a little bit the business understanding and a broader view on the technical topics. So not only why a technology is working, but why is it needed, and why is it being integrated, and what kind of technology is going to be successful or not. And it's not only a question of how good this technology is being designed; it's also a question of how big is the demand. And to teach you this and to get a little bit an understanding of that, it is not only the scientific basis, but also a little bit the business basis. That's the second reason for my course. And the third reason, it's a very private one. I have 3 children, and my oldest daughter, she got the privilege to study in Budapest at the Semmelweis University Medicine. And I found it extremely caring of Budapest to take my daughter. And she loved it. And this is a small piece I'm giving back now to you guys. The lecture today, and I actually don't want to call it a lecture because it is more a summary of my overarching lecture. And it's a little bit like putting an elephant into a refrigerator. It doesn't fit. So I need to press 1 year of lectures into 1 hour or 1.5 hours. And I most likely do the same mistake as my employers normally do. I have too many presentations or too many slides, so I need to cut it during my verbal speech here. The idea is we discuss the disruption in the transportation industry. What kind of changes do we have? What are the business reasons behind those changes? What are the technical reasons behind those changes? And at the same time, how do we manage it? So how do we drive the right decisions? How do we drive the right prioritizations? How do we come up with the right strategy? And how do we set up the organization for managing the situation? So I would like to start with the disruption. And this is a picture of New York in 1900. I don't know whether you have seen this picture before. It's on the Broadway. And what you can see is a lot of horse coaches, horse coaches. And you see one car. Do you see the car? I help you, okay? It's there. So there's one car on the Broadway. No, actually it's not Broadway, it's Fifth Avenue. 13 years later, on the same spot, a picture is being taken, and it looks like that. So you have suddenly all cars and one horse. Here you see the horse coach. So in 13 years, the complete transportation has changed. And that is a disruption. And that is what we currently face in the transportation industry as well. The mega trends we are having on a principal basis are derived out of the mega trends of society. And the mega trends of society is urbanization, sustainability, digitalization, and mobility. Everybody wants to live in cities. We all know that the climate change is going needs to be solved, or the climate change is solving us. Everything is going to be digitalized right now. AI is in every mouth. And last but not least, everybody wants to be mobile. And out of this, the trends for the truck industry is traffic safety, automated driving, connection and digitalization, and emission reduction. And in all of those areas, a disruption currently is taking place. We have the automated driving. We are on the way of having trucks without any driver, and that is dramatically changing the way how a truck looks like and the way how a truck is being used. We are having the complete logistic chain being digitalized. We have, and out of the digitalization, the topic of cybersecurity. We are having on the traffic safety the interference between immobility, digitalization, and automated driving. How to make sure that a truck is safe, ISO 26262. And last but not least, we have the necessity to reduce emissions. And believe it or not only the cars are being electrified, also the trucks. And the biggest hurdle we're having is that we have 4 disruptions at the same time. So it's not only 1, it's 4. And the complete industry is currently struggling because they don't know where to focus. Now let's look. What does it mean for the trucks itself? On the left side, you see the trucks, how they look right now. Classical truck, straight truck or semi-trailer, buses, all of them with a combustion engine. The technology is well known. It's changing a midterm to electrified trucks and the first automation. And on the right side, you see the trucks, how they look like in 15 years, 20 years. So if you take a look on the truck on the top, or maybe actually take the truck in the middle. In the middle, you have a trailer and you have 2 small chassis towing this truck. This chassis doesn't have any cabin. It doesn't have any combustion engine. It's irrelevant how comfortable the truck drives, because no driver is on this truck anymore. And this has, in consequence, an utmost change on the way the truck is being designed. Why is there such a push towards those disruptions? And now this is the first thing. We always do this bridge in my lecture between the technology and then the business. It's all about money. The logistic industry, and that is also what you will learn. There is a picture of the red ocean and the blue ocean. The blue ocean, there's fun to swim, and there are no sharks, and you are on your own there, and you get a lot of money, and it's all good. The red ocean, there are a lot of sharks, and this is a picture. So a red ocean business is where you have a lot of competition. And a lot of competition means that the prices are going down and the cost pressure is extremely high. And a logistic industry and also the automotive industry is red ocean. You have you have overcapacities, you have too many providers transporting your goods. And in consequence, a truck is not earning any money except of the last couple of days of a year. But that means that your processes need to be completely optimized, and you're trying to save money wherever it's possible. Now, if you take a look on the TCO is the total cost of ownership. It is not relevant what a truck costs. It's relevant what your complete costs for a truck over the lifetime are. And this is what we're analyzing together, and you will find out that a significant portion of the cost is fuel, and it's the people, it's the driver. And it's, at the end of the day, also 5% is insurance. And that is driving the megatrends. That is driving the push for automation. It's the push for getting a truck as efficient as possible. And that's, by the way, a reason for battery electric trucks. And last but not least, it's a push for safety, because if you get the insurance significantly down, that's a benefit for you. Now take a look on the logistic chain. As I said, the logistic arena is red ocean. But a red ocean for you guys to work at, it can be extremely fun, because a red ocean company is a company which is super professional, which is super automized, which is super digitalized, and where they really know how to do the business. And this is the logistic industry. So there is a lot of change right now. The complete industry is going to be digitalized. As I said, they're using the big data. All of the trucks have telematics. In the future, the telematics are being used on defining the health of the truck, but also knowing where the goods are going. This is really interesting. So companies like Google have a big interest in order to get this information. There is a lot of change with respect to the globalization, even though there is a lot of protectionism on the horizon. It's still a global world. The warehouses are being managed by smart robots. We have a lot of different channels in the future. Train is becoming more relevant, and last but not least, it all needs to be sustainable. Now, if you take a look on the digital logistics, it is not like that an old truck is going from A to B, and you have a not very educated driver driving this truck, and we can all smile a little bit about the logistic companies. This chain is completely automized. It starts with the quote. It goes forward to how the quote then at the end is being accepted. There is going to be what we call what's the Börse in English? Stock market. So the shipper is putting his offer on the stock market, and the one who is needing it is taking it. This has a consequence on the routes. So the routes are not anymore from A to B. They are going to be dynamic. The routes are being dependent on what kind of goods do I have in my truck. The trucks will be then from a hub to a hub being driven automated. The trucks on the grounds, on the warehouses are being driven automated. They're being loaded and unloaded automatically. And last but not least, all the documents are being generated also automated. So it will be a complete chain. But that has consequences. If every truck is being connected by telematics, it's very easy to hack into this truck. Now, imagine you have a 40-ton truck loaded with gasoline. This is a weapon. And you don't want this truck to get in hands of terrorists, just as a picture. So in consequence, when we digitalize the truck and we put telematics in the truck, we also need to take care of cybersecurity. And how does it look like, and how is being managed, and what kind of legal requirements are being set up? This is what we also learn in my lecture. Traffic safety as a second disruption. It's simple physics. If you have a truck with 40 tons driving 80 kilometers an hour, and you compare the collision energy with a car that is driving 100 kilometers an hour, but weighs only 1.5 tons, it's 15 times more. It's just the weight. The velocity goes in by square, but the weight is just fundamental. And if you have a truck who is driving at the end of a traffic jam, that is not only a problem with respect to the fatalities you're having and with respect to all the damages on the logistic chain, it's also a social issue. If you suddenly have 3, 4, 5, 6 people being killed in an accident like this, the society is not accepting it. And that's why the laws, the safety laws for a truck are significantly higher than the safety laws for a car. You have automated emergency braking for a truck. We had ESP being legally required already 15 years ago. And something like this is not yet foreseen in the car. At the same time, accidents which are being so fundamental are changing the technology. And this is an example of Herborn. Herborn is an accident that happened 20 years ago in Germany. It was a truck that drove down in a village down the hill, and the brakes of the truck overheated. They had drum brakes, and it has loaded gasoline, and it exploded in the village, and people in a house got injured or got killed. And the consequence was, because of this accident, that the complete brake system of a truck changed within 5 years. There's no truck in Europe anymore that is using drum brakes. They're using air disc brakes, and that is one of the reasons here. Now, coming to the reasons besides the social and ethical reasons to very much focus on safety, it is the cost. It's again the cost. If you have a truck that is getting in an accident, it's not only that the truck is broken, and it's not only that maybe other cars are broken, and not only that even you have payments for people who are injured or killed, and you have legal claims. The logistic chain is broken. And right now, everything is just in time or just in sequence. So if your truck with, I don't know, 1,000 air disc brakes from Knorr-Bremse is broken down and it cannot be delivered, then 200 to 300 trucks are not being able to be built. So the production chain is being ripped apart. And the consequence is that the logistic companies is failing a lot of legal claims from the customers. And that's the reason why safety is such a relevant issue for the trucks. There's a lot of legal requirements behind there in Europe, in North America, in China. We discuss all the background of the norms and of the laws being released. At the same time, it's not only important to have the safety systems in a truck, it's also important to develop a safety system safe. And it's important to define what is a safety system. And it's important of finding cost-relevant measures, not to have every safety system as an S&D system, but make a decompensation and reduce the ASIL level maybe to B, and how to get there. So this is a special lecture we're having, and from my perspective, it's actually one of the most important ones, because automated driving, and I mentioned this in my last lecture a couple of weeks ago, automated driving, Europe is already behind. E-mobility, Europe is already behind. On digitalization, so. On safety, we are still number one. This is still our core, and we better not let this go. So third mega trend, electrification. Nine years ago, I never thought that a truck, a 40-ton truck going on long haulage will be electrified. I thought it will be for cars. They have a weight of 1.5 to 2 tons. They're getting a battery of 70 to 80 kilowatt hours, and that's fine. But the trucks will be electrified. And there is no way back. And the crazy thing about this is that it's not only a political and a social reason why a truck is being electrified. Midterm, it will be a cost reason. Because electrified trucks with a total cost of ownership will be more, it will be cheaper than trucks with a combustion engine. There is a hypothesis for that, and I think this hypothesis is materializing, that the energy transition is being mastered from fossil energy to regenerative energies, that the grid problems are being solved, that we are going to have a charging infrastructure which is sufficient. But if this is the case, there will be no alternative to electricity as a fuel in the future. One of the turbo for the electrification of truck is a law by the European Union, and it requests that a truck needs to reduce its CO2 emission by 45% with respect to 2019. Now, knowing that a truck is already super efficient, if you have a truck, a 40-ton truck, that's out of my head. Don't kill me if I'm a couple of liters wrong. It needs round about 30 liters per kilometer, per 100 kilometers, roundabout, fully laden. If you compare this with a car that is pretty and you make it proportional to the weight, that's pretty efficient. And there is not much more efficiency able to be gained in a combustion engine anymore. You can be a little bit some aerodynamics, but let it be 5%. That's it. So in order to get there, you need to electrify your trucks. And if you don't do it, the penalties on the truck manufacturers are so high that they're currently even selling their trucks, the electrified trucks, basically without earning money or actually even giving money to the buyers. Now, to see what is the right technology, we need to take a look on the efficiency of this technology. And there is a statement from the well to the wheel. So if we look on the right side and we say we need round about 1.5 kilowatt hours for a laden truck per kilometer to drive because of air resistance and rolling resistance, then you have, for a battery electrical vehicle, you need 1.6 kilowatt hours. That's pretty efficient. If you compare it with a catenary, that is a technology that most likely doesn't come. Catenary is basically a train for a truck. So you have lines on the autobahn, and you have a pantometer, and you hook up to this line when you're on the autobahn, and you get your electricity. So you don't need a big battery. And if you get off the autobahn, then you drive with a small battery. But to build up this infrastructure is too expensive. The fuel cell is double as bad as the battery electrical vehicle. And that's because of the fuel cell itself. The fuel cell is not very efficient. It has an efficiency of around about 60%. And in order to generate the hydrogen, it's also a not very efficient. So you end up with 3.8 kilowatt hours per kilometer in order to drive then at the end on the wheel with 1.2 kilowatt hours per kilometer. The hydrogen engine is even worse. It's not from generating the hydrogen, but it's worse from the drivetrain itself. And last but not least, everybody, and we had this discussion in Germany about the synfuels. So keeping the combustion engine alive and using synfuels for driving with a normal combustion engine, it's 7.8 kilowatt hours per kilometer. So it's factor 4.5 with respect to battery electrical vehicles. And that is the reason why there is a big trend towards battery electrical vehicles, or I phrase it differently, battery electrical vehicles will be the truck of the future unless you have an infrastructure or unless you have a driving profile where you need a fuel cell. Also here, we do a total cost of ownership analysis. And if we do a total cost of ownership analysis and the details will be discussed in the lecture, you will find out that we are not yet on parity, but in a couple of years, a battery electrical truck is, from a total cost of ownership perspective, cheaper than a combustion engine. And that will be the tipping point, and this will be then the time when there will be a boost in battery electrical trucks. There are different motivations for battery electrical trucks, as the use case in logistics are very different to the use cases in cars. In a car, a car is a car. A car can be a little bit bigger or smaller. It can be 1.5 tons or 2 tons. It can be like 20 centimeters higher or lower. A truck is from 7.5 tons all the way to 40 tons. It is a use case for buses, which is very different to the use case of a distribution truck. Is very different to the use case of a long haulage truck. Is very different to a use case from a hub-to-hub truck. And for those different use cases, you need different technologies. Now you have, for the city bus and for the distribution truck, you will most likely have a battery electrical truck. And the motivation is here less the TCO, and it's more the zero emission in the cities. On the long haulage, it's different. There you have very clearly the reduction of CO2, and also coming more and more relevant, the total cost of ownership. And in consequence, the city bus will be battery electric, or the distribution will be battery electric because you don't drive so many miles. And the long haulage will be either battery electric or fuel cell. Now the introduction scenario looks like this. So nobody knows it by heart. McKinsey was very optimistic. FEV, this is a engineering provider, is not as optimistic as McKinsey. You see up there the change for United States, Europe, and China for the different use cases, long haulage and distribution. And you can see that battery electrical vehicles are being dominant for distribution and being on pari with fuel cell. The increase will start at the end of 2020, and till 2040, most of the combustion engines in Europe are gone. And you guys, this is 15 years. 15 years is nothing. In 15 years, actually, what you should think about is when you're making a real estate investment, you should really take this into consideration. So if you're currently thinking of buying an apartment on a heavy polluted road, this road will not be heavy polluted in 15 years anymore, neither by cars nor by trucks. Automated driving. I probably say it's just a matter of time. And you guys, it's just a matter of time. And it's a little bit the statement, in 5 years we will drive automated, and then in another 5 years we will drive automated, but now it really is happening. It's happening on the truck industry and it's happening on pass cars. I drove it myself. I drove a Waymo car in San Francisco, and I read it yesterday in a newspaper in Wuhan. You know, Wuhan is the city in China where the coronavirus was founded. It's in Wuhan. The Baidu is also driving automated, also without any drivers. They have a couple of hundred taxis there driving around. When we discuss automated driving, we tend to always look on the technology and on the challenges on the technology. But you guys, and I a little bit look at your rector, because he is an expert on artificial intelligence, and he knows probably it better the details than me. But it's creating the algorithms and putting a car on the road and training this car. This is one thing. And I would say 10 companies worldwide are already there. Validating and releasing this car and driving this hundreds of millions of kilometers in order to be sure that every situation is being trained. This is the other thing. The question is, when is the training over? And when is the car and the truck safe? And that is something that is not easy to answer. And there is actually no agreement yet. You have companies like Tesla who are using the owners, the car owners, as test drivers, and you have the Germans who never dare to do something on this area. So probably the approach will be in between. But it is really a dilemma this industry is in, how to release a truck, 40 tons, a truck to drive automated. This is one problem. The second problem is, and it's shown here in this picture, it's an ethical problem, and an ethical problem in multi dimensions. You have ethical issues because you don't need any truck drivers, so you eliminate all the professionals. But you also have ethical problems when it comes down to decisions. I see a couple of students in my lecture here, so they probably heard what I'm saying now. But it's a dilemma when you are in a situation where you can only decide between bad and worse. So either you go in an accident and kill somebody in a car, or you go for a maneuver and you kill a child which is running on the street. So how do you decide? And the problem is, as a driver, you will be in the same situation. But as a driver, it is your responsibility. And you act according to what you think is right. As an automated driver, you need to be trained for this situation. And this situation needs to be discussed. And you discuss ethical problems which have not been released, or where you don't have any understanding of how to act in this situation. And that is a problem which is coming up now. Also on automated driving, we make a TCO, and we go in all the details. And it sounds so easy to make a TCO, but a TCO on a principle basis is quite complex, because you need to look upon all the different aspects, from investments, from building up an infrastructure, from fuel costs, personnel costs, insurance costs, and so on and so forth. And if you do this on the automated driving, you will find out that level 4 is reducing your costs from €2 per kilometer to 1.6 euros per kilometer. if even the driver is out only on the highway. So that's a hub-to-hub. It's 40 cents reduction or 20%. Now, in the industry where the logistic companies are earning the money on the last days of a year, if you're able to reduce your cost by 20%, this is a game changer. And that is the reason. And actually, how many truck drivers and how many logistic companies do you have worldwide in comparison to taxi drivers? And I dare to say it's much more. And it's much more a business case to get the trucks automated than to get the taxis automated. One aspect. The second aspect is that getting a truck automated is much easier because it drives in a pretty known situation. It drives from on a highway from a hub to a hub. You can train this highway. The situations are much more predictable than they are in the city. So that's the reason why McKinsey is strongly feeling that it's coming. It was foreseen that the first trucks are on the road in 2024. That is not the case. I would say we are still 2 to 3 years behind this date, but it does come. And I also drove it myself. It's pretty amazing. Now, there is not only a change in the industry for the automated driving with respect to the truck and how the truck looks like, and that you don't have any cabin anymore, and comfort is irrelevant. There is a change with respect to the companies who are doing it. Question yourself, what is more important? Is it more important in the future to deliver a chassis with an electrical drivetrain? Or is it more important to be the one who is delivering the automated driver? You can make your own judgment. I make my judgment. I would say the automated driver is the key. And that's the reason why the Googles and the Apples and the Too Simples and the Baidus are going in this direction. And the dilemma we are in, again, as a European, actually even as a Western industry, is that we are behind. So we will not be the ones who are doing this automated driver. It will be the Auroras, Waymos, Embarks, and Too Simples. And they're on the way. And Waymo is already talking about a truck manufacturer as a tier 1. A tier 1 is a supplier. So Waymo is not considering themselves as a supplier to Daimler or to PACCAR or to MAN or to Scania. They are considering the Scanias, the Volvos, and whoever as a supplier to their automated driver. So it's turning. And the complete industry is turning. And a couple of us are just sitting there and watching. Knorr-Bremse, fortunately, has not been watching only. We are the ones who are doing the complete optimization of the operations. So we're doing the steering and the braking and the redundancy for those trucks. And luckily, we are in probably 80% of the running projects. I showed you this already, how this is the business model is changing. Now, when we discuss automated driving, we need to understand also what is automated driving and what kind of level do we talk about. I mean, Tesla always says, I do automated driving. That's not true. There's a clear definition of automated driving. Automated driving is when it's level 3. Level 3 is when you when the driver is out for at least 8 seconds. And level 4 is when the driver is completely out, and level 5 is when the driver is out in all driving situations. Level 2 and level 1 is just a driver assistance system. So the Tesla is nothing more than a driver assistance system because it's level 2. But we go also in the lecture in more details here. So, when we now see all those changes ahead, and you're leading a company, what would you do? Where do you put your resources? Do you put it on digitalization? Or do you put it on automated driving? Or do you put it on e-mobility? Or you don't put it on anything, huh? Because it's too much anyway. So how do you lead your business in those times? And when we take a look at this, I come back to my original statement. When we have a situation of disruptive innovations, we need to understand what is an innovation. And innovation is not something which is innovative. The innovative part is one part of an innovation. An innovation must be successful. The combination of success and innovative product for an innovative product is an innovation. And you find hundreds of smart ideas which were not successful, and somebody picked it up and suddenly became successful. Do you think that Steve Jobs did invent the iPhone or the core technology of the iPhone? He did not. The core technology, the touch screen, and the controls behind the iPhone, he purchased by another company, which wasn't successful. But he had the idea of setting up to implement it into the iPhone, and that made him successful. The MP3 player, it was invented by a German university, but at the end it was not successful. It became successful in the United States. So to smell what is really going to be successful, that is sometimes even more important than the innovation itself. And what is also important is that you find the innovation at the right time, and you find people who are willing to look and listen to the innovation. And this picture, I would say this is symptomatic. So you might have the best idea, but if you don't find people who are using this because they are so busy of doing something else, then the best idea will not be successful. The basis for an innovation management is the basis for a good innovation is innovation management. And the innovation management must be implemented into the company. And the innovation management, the basis for the innovation management is the innovation process. And it starts all with a technology foresight. It goes over to the innovation strategy, then pick up the right spots into an incubator, and out of this, you end up with a list of projects and a project prioritization. And in order to come to this proper innovation process, you need to have the right strategy. And the right strategy is an input parameter. You see it up there. And a strategy also is not given. A strategy also is hard work. And we come to this later. A strategy is an ongoing process in a company. Like the innovation process, a strategic process is ongoing. And it starts with a long-term strategy. And it goes to the midterm strategy and then to the short-term strategy, the financials. And the input parameter for the midterm strategy is a long-term strategy, the vision of a company. Where do you want to go? If you don't have a vision for the company, and if it's not well defined, you are not able to define the right questions and the right strategy for midterm. You don't end up with the right product strategy. So what is your vision? What is your focus? What kind of trends are going to be in your arena? Where do you need to set up new areas out of your existing portfolio? That is the long-term strategy, and that goes into the strategic planning. And when you go into the strategic planning, and by the way, I'm rushing now through this all. This is probably half a year of then discussion inside the lecture. Then you need to first ask the right questions. So you need to question, what is your environment? You need to question, what is the internal solution, internal situation? Where am I strong? Where am I weak? You need to question, what kind of situation out of my problems, which situation will I be involved? Then you need to question yourself, what are my options? And this is a very principled questions. You can use those questions on many strategic problems, but you need to question it. And when you do this, then you go in the more analytic discussion on strategy. And by the way, when I talk about strategy is really a broad discussion. Strategy can be an operational strategy. Strategy can be a personal strategy, a cultural strategy. Strategy, in my case now and also in the lecture, is more focusing on product strategy because it's looking on innovation. Now, if you want to get to the right product strategy, you need to discuss the portfolio. And in order to discuss the portfolio, you need to have an external and internal views. And here also there are analytics helping you to do that. And when you do this, and we also train this in this lecture, you end up with a market position analysis on one side, a technology portfolio analysis on the other side, and combining both will be then your portfolio analysis, portfolio prioritization. When you have this prioritization, then you need to do a discussion of how to manage it. Do I do it internally? Do I do it externally? Do I have the right capex budget? And so on and so forth. Do I make it myself, or do I buy it from somebody else? This is then always a cost discussion or a strategic discussion. But all those questions, and now this is one fundamental part of the lecture. All those questions move into a business case. There is no decision in the industry, or at least let's put it this way, there's no decision in a good led company without a proper and transparent business case. So what is a business case? A business case is trying to combine the economic and business factors and the strategic factors into one number. Is it worth investing? Yes or no? What is the payback? What is the return of invest? And the input parameters are costs. The input parameters is market. The input parameters is sales. How many units do I sell? The input parameter is what kind of price do I earn for this? The input parameter is what kind of investments do I need to take? Even all the way down of what kind of R&D do I need to have for a certain product? But it all aggregates into one number: return of invest. And this is if you have swallowed this at the end, after all this lecture, and you are prepared of doing a business case, not only for your company, but maybe also for some private judgments, then you have learned something. Now I'm coming in the last 5 minutes to my end. If you have the right strategy, if you have the right portfolio, if you have the right innovation, then you need to adapt your organization. It is not possible to develop as you have developed 20 years ago. Multiple things changed. From the complexity of a software to the way of speed, actually to everything. And there is one way of doing it. It's called Agile or Scrum. So there is a big trend in the industry moving from a classical hierarchical organization to a more agile organization. And what you can see here on this picture is the unhappiness of customers. So you will find out that everybody in this industry is not able to keep their budget, is not able to keep their timelines. They are 1 year, 2 years late. Read it on Conti, read it on Volkswagen when they're delaying their models. Also, Knorr-Bremse failed on keeping a certain timeline on the latest brake system. The way forward is, as I said, agile. And agile means it's a fundamental change of thinking in organization. You move away from processes and tools and more to individual interactions. Of course you have processes, but the processes are not that dominant anymore. You move away from a comprehensive documentation to a working product, all the way even down to a prototype. You're using your requirements, which you document as a documentation. You don't write an essay anymore. You move away from a contract negotiation to a collaboration. You say, you know what? I put it on the table and we discuss whether this is good or not, because of short recursions. And you don't follow a plan of 5 years. You're responding to a change. So you don't have this project plan of milestones for the next 5 years. You know only the next step. You have a rough plan and you know the next steps. And then you learn on your step. And then you learn. And then you learn. And suddenly you become faster and faster and faster. But that has consequences. That has consequences on how an organization is being set up. That has consequences on the roles and responsibilities. That has consequences for the people themselves, because the people are not the VPs anymore, and they're not the director of engineering anymore. They're the product owner suddenly, or the meta product owner. So the organization needs to learn how to live and work in this environment. On the spot, 6 o'clock. Thank you very much. Yeah.
Thank you, Dr. Steinberger. Now we have time to discuss everything what was in the presentation. If you have any question, please raise your hand, and please wait until we give you the microphone. Thank you.
Hello, sir. Should I stand up? All right. So thank you for...
I see you.
Okay. So thank you for your presentation. I really enjoyed it. First of all, I would like to question your university. You studied at the University of Applied Sciences in Munich?
No, Technical University of Munich.
Sorry. So, okay, then let's jump. Then I would like to ask one question. Have you ever taken part in planning long-term or mid-term strategies at the company?
Say it again.
So did you ever take part in thinking or, excuse me. So did you ever planned, or have you ever planned any long-term strategies for Knorr-Bremse?
Yes. I was leading the managing board for 9 years. So it was my job. Yes. Did it answer your question?
Was a dumb question. Things are not.
No, it wasn't a dumb question. It was no. I'm sorry if I make you feel like this. No, it was not a dumb question. It's let's put it. Maybe I take your question and explain it a little bit more.
Okay.
Then no. Let me explain a little more. It's a question of the hierarchy. And first, at Knorr-Bremse, every employee works on the strategy, more or less. It depends on which depth, in which detail, right? So an engineer is working on the strategy by providing information on its engineering project in order to be able to judge the prioritization and define the project roadmap. If you are a vice president, you define the strategy for your business unit, which is a central part of it. So it's a strategy, a strategy, long-term or especially mid-term, is not a unique building. It's a building out of all different kind of aspects. So you have a strategy for a business unit wheel end. You have a strategy for the business unit vehicle dynamics. You have a strategy for purchasing. You have a strategy for engineering footprint, and so on and so forth. So, and the overarching of this is the strategy, because this is then resulting in a financial planning. And me as leading the company, I was responsible at the end for the entire process of the strategy, and I had all my colleagues working on their details.
Okay, thank you. So actually, what I don't understand or don't know is that what does it take to to have enough knowledge? What knowledge does it require to make a strategic planning and a good strategic plan? Because I would assume that it would need, you would need experience in your field of work, but also you would need experiences or knowledge outside of your work, like society-wise. You should know a lot about things, right?
First, you learn it by the years. Second, to lead a company and then also to be able to have a strategic mind means that you're constantly open and think on the interfaces and to make it a successful strategy, from my perspective, is to have. Now, this is very subjective. I would say you need always to be insecure, not as a person, but insecure whether what you do is enough and sufficient. And if you're insecure all the time, that whether it's really sufficient or not, that makes you go the extra mile and look on the competitors and look on the technology of the others, and it prevents you of being ignorant. And the ignorance is the death of a good strategy.
Thank you. If there's no one else wanting to ask questions, I would like to have one more, if it's possible. So I have, well, usually people think, or young people at least think, that older people are harder to accept change or to go with the trends. Is it true in, let's say, in a board of directors where people are usually older? Is it a problem to acknowledge change?
I think it all ends down to the way you're socialized and your character from the very beginning. So there are people who are open for change. There are people who are more daring for something new, and there are people who are afraid of changes. And that has nothing to do with the job. First, it's inherent with the character. Now, I would say if you are becoming in the board of directors, you normally have at least a tendency for being a little bit more brave and more open for changes. Otherwise, you would not end up in this position. Does it answer your question?
Yes, thank you so much.
Thank you for your presentation. It was amazing. I enjoyed it a lot. My question is, what is the best way to connect my engineering studies with more economical-based knowledge?
I don't know what kind of courses you get here at university.
I'm taking mechatronics.
I'm sorry?
Mechatronics. I'm on mechatronics. Mechatronics engineering.
Taking mechatronics.
Mechatronics. Okay. I look now at the professors. What kind of courses you normally offer here for business as you know, supporting that? Because actually I love your question. It's for me exactly the right question, because that's what I would encourage you if there are any lectures. But that is something I would give to you. But I would answer you another aspect. I would recommend start reading business papers. I would recommend to read in the newspaper on how the economy is doing. What are the business decisions? What is ZF currently doing in Germany? And I'm not saying this because it's a competitor. It's just because it's in the papers. What is Volkswagen currently doing? Why is the background? Then Google it and try to find the backgrounds for this, and that would help you enormously, because it's, you know, by having those practical understanding of the situation, of actual situations, you're deep down in the problems. And I grant you one thing. If you, at the first probably 2, 3 weeks, 4 weeks, it's tough, because it's a little bit boring and it's theoretical and whatever. But once you understand the knots who are interconnect, then suddenly it's fun. And then I got most of my knowledge actually by reading it myself, to learn it by myself.
Okay, thank you very much.
Hello, sir. Thank you. I'm curious, did Knorr-Bremse start out as a traditional hierarchy structure? And or did it start out as an agile network? And if it did start out as an as a traditional hierarchy, how did you transition, or did you transition into an agile network? And what are like the recommendations that you would give for a transition from a traditional network or a hierarchy to an agile network? Thank you.
So yes, Knorr-Bremse is a classical hierarchical company, and it's a little bit a philosophy how you change, and we do it differently in the regions. So North America has changed completely from a classical hierarchy to an agile organization all the way through, with a lot of pain. Europe has chosen differently. Europe has chosen that we're doing it based on projects and products, and we don't want to force the people in a new organization. We want to encourage the people in a new organization, and that means that they need to be enthusiastic. So we more believe in a pull principle than in a push principle. And so we had the trailer department, trailer electronics, who completely changed into agile, and from this department it's now spreading. We have our incubator, which is our innovation arena, is agile. We have portions of the software development being agile. We have the transmission control now being agile. So it's spreading. We have automated driving. as an agile organization. So we're doing it step by step. Because we are a little bit afraid, besides this push-pull principle, we're a little bit afraid that if you are doing too much, that you're losing your culture, and nobody knows what to do anymore. And we were afraid of that. We didn't want to get stuck in the age of transformation.
Thank you. Well, thank you for your time. I have two questions. The first one is, in your opinion, regarding sustainable mobility, what do you think it will be the role of fuel cells vehicles compared with common electric vehicles in the next 10, 20 years? And the second one is how automotive business deal with volatile or changing battery prices.
I couldn't hear you.
Sorry, like neither of the two or just one of them? So the first one...
Take it off and say it without.
Sure. So the first one is, in your opinion, regarding sustainable mobility, what do you think it will be the role of fuel cells vehicles compared with common electric vehicles in the next 10 or 20 years?
Mm-hmm.
And the second one is how business deal with volatile or changing battery prices.
Battery price.
Thank you.
Okay. So first question. Also, this is a little bit of belief. You will ask 5 experts and you will get 5 different answers on the fuel cell. My opinion is that I believe that the fuel cell is a bridge technology, and it will not play a major role. I believe that there will be only for certain applications where construction vehicles, for example, where there is even more the H2 combustion engine. But for certain applications, there might be the fuel cell, in particular in the United States, because you have really long distances. I believe that the logistic processes will change a little bit, giving the trucks more time to charge. I believe that the battery electrical vehicles are so efficient in comparison to the fuel cell that it doesn't pay off. So it's the total cost of ownership from a fuel cell is way too high to really spread out in common. So I believe the fuel cell will be 15, maximum 20% of the vehicles in Europe. Okay. Now to the batteries, the truck has the advantage. They are not on this. There are 2 different kind of batteries: the lithium batteries and the nickel iron batteries, I think it was, and the nickel iron batteries. But don't catch me here. I need to read it for tomorrow anyway. I think the nickel iron batteries are by far less expensive, but they don't have this energy density. But they are able to use more cycles, and those batteries are being used for the truck. I believe that the batteries will drop dramatically in price. Currently, they are in the range of 100 euros per kilowatt hour. They will drop by 50% till 2035. And if you have a truck that needs, I don't know, 500, 600 kilowatt hours, you normally you need 100 kilowatt hours per 100 kilometers, roughly. So if you have a 500, 600 kilowatt hour battery, and this battery costs in the future around about 30,000 euros, that will be roughly the price you need to think in 10 years. Then the question is the solid Festkörper battery. What's the name of it? Solid. No, that's not solid state. Solid something. So not the liquid batteries with a liquid cathode, but with a solid cathode. They will come, but they will come in 10 years, 10, 15 years. Does it answer your question? Okay.
First of all, thank you for the comprehensive summary. My question would go for Europe compared to Asia and US. What you mentioned that Europe's competitive advantage is now only in safety, and we lost in cybersecurity, digitalization, and also mobility. And the question would be what you see, or where do you see the bottlenecks, why we lost this competitive advantage, and how long our advantage will last in safety?
I stated during my analysis on strategy. You asked me what is necessary for being able to do a good strategy. My statement was ignorance is the killer of a good strategy. I would say that the Western truck manufacturers were ignorant for too many years. They were, and also the car manufacturers. They were ignorant on the changes on the battery electrical vehicles. They were ignorant on changes on how to design a EE architecture for a car and a truck. They were ignorant on focusing on setting up a proper software and control system. They were ignorant on believing that the most relevant stuff for somebody who's purchasing a truck, or in particular a car, is how good are the tolerances of the doors, which is just ridiculous. Now that happens. How do we gain ground? I believe that for a truck, how to design the drivetrain and how to design the cooling system for a battery electrical truck is pretty relevant, and that is not in the hands of China, as the batteries are. So there is enough in the drivetrain in the future to differentiate. I believe that the last word on automation is not spoken yet, because it's one thing to. Sometimes it's not necessary to be the first innovator. Sometimes it's enough to be the fast follower, and sometimes it's enough to make it then better. So if you take a look on the automated drivers right now, they all run on NVIDIA platforms. They need roughly 2 kilowatt on power. 2 kilowatt. This is a heater. My heater in my house is 8 kilowatt. I have 180 square meters. It's 8 kilowatt. So just to give you an idea, 2 kilowatt is absolutely not acceptable as a power for an automated driver. Now to bring this automated driver now in an automotive environment, that is where what we call will be the next round, and that could be again the chance for the manufacturers. They will not do everything on their own, but they will try to become the system integrator again. Yeah. So and this is a battle. So let's see how this involves.
Thank you. And another question, just it's not a question, it's just could you elaborate on your vision, how you imagine or how you expect the electricity grid will look like in the future. I mean, as a personal driver, if I have an electric car and I charge it at home, then it's maybe cheaper per kilometers compared to benzene or diesel cars. But for trucks, if I use Ionity chargers or public chargers, the picture is more complicated and prices got really comparable. So maybe in some countries it's even more expensive to per kilometer. And in your total cost of ownership analysis, it showed that it's really 20% cheaper. And then how you imagine the charging grid in Europe in the upcoming years, and what do you think where the energy will come from?
I would first come from the truck and then go to the grid and to the infrastructure. The trucks who are designed yet as electrical trucks are not cost optimized. If you take a look on the Volvo truck, it still runs with a transmission, an I-shift, because it was just fast. It was faster to do it this way. There will be a second and third generation of trucks which will be absolutely optimized for electrical drivetrain, and those will be a little bit cheaper. So, and also the prices for electrical trucks will go down as soon as the numbers pick up. So it's always to come over this tipping point. The infrastructure. If you take a look on United States, most of the trucks, I talk about a long haulage. I'm not talking about distribution, but distribution actually is the same. The significant amount of trucks return at night to their stations. A significant amount, because the truck drivers don't want to go from coast to coast anymore. Some of them go from one hub to hub, and then they switch and then take the other truck back home. So if you go from a hub to a hub, what you need to do as a logistic company, you need to electrify your hub. So you don't need to have all the charging stations all the way down the highway. You need from hub to hub first. Second, when you are driving as a professional driver, you need to have rest hours. So after 4 hours or 4.5 hours, you need to rest for 45 minutes. That gives you time to charge your truck. So you don't need more than 500 kilometers or 600 kilometers in once, because not even, because you need to rest anyway. And now, how to build up this grid? I can only share my vision, okay? Of course, the grid will be built up, in particular, either on the highways, and of course, it's not possible to build up at certain places charging stations, because the grid is just not yet there. But why don't we build up for those situations mobile fuel cell stations? Why don't we use H2 at least for a certain period of time to charge the battery electrical trucks? My view is, and I'm not saying I'm right. I'm just giving you a thing for thinking it. Why do I need to drive always a fuel cell truck, which is not very efficient, instead of driving a battery electrical truck and using at certain places where I don't have a grid, a fuel cell, in order to get the electricity decentralized on the spot? That's a little bit my vision.
You have stated that Tesla is mainly a driving assistance company. However, the mainstream media tells us that they are researching automated driving heavily. You emphasize this because there are other companies that are doing a better job, and if so, which are they? Thank you.
Was it a question? Which companies are doing a better job?
Yes, that would be.
So in the first place, it's not a hypothesis that Tesla is currently on level 2. It's a fact. Because a level 2, level 3, level 4 needs to be officially released, and Tesla is officially released on level 2. The only company who is, or actually, I think the only 2 companies on cars who are officially released on level 3 is Mercedes and Audi. And on level 4, Waymo and Baidu are doing it significantly better. They are driving autonomous in San Francisco and Phoenix and in Wuhan. So how do they do it better? I think they are. I think first they have a different setup from the sensors. So Tesla still believes they can do automated driving only by cameras, and it's a matter of fact that every sensor has its strengths and weaknesses, and a camera is not necessarily really perfect for distances. They can do it by certain methods, but it's not perfect. And a radar sensor and a LiDAR sensor are perfect for distance. So the combination is, from my perspective, necessary. And Baidu is working with radar and camera, and Waymo is working with LiDAR. I think LiDAR, radar, and camera. And I think they are just more professional on setting up their safety cases, their test environments, and things like this. The only benefit Tesla has, from my perspective, is they have an unbelievable amount of data. This is giving them a big advantage because they have, I don't know, 500 or 1 million cars driving around and providing the data, and Waymo just don't have so many cars yet on the road.
Thanks for your presentation. I was curious about what's your opinion about alternative transportation methods? I mean, you mentioned trains, but you also talked much about hub-to-hub transportation by trucks. Don't you think trains are better alternatives?
First, this is a very good question. Big compliment on this question. It's really good. I believe that a truck hub-to-hub is more flexible. Because if you move on a train, I actually would be interesting. This would be really an interesting topic. I'm pretty sure you can calculate this mathematically. I dare to say that it is the amount of goods on an autobahn is much more than the amount of goods on the train, because you need to have a certain distance between the trains, and so I believe there's only a certain amount of trains on the track possible. So it would be really interesting where can you transport more goods per kilometer on the train or on the autobahn. I dare to say on the autobahn, but this is just a hypothesis. If you have ever seen a hub to train in North America, do this, Google this. This is huge. And then the trucks come there, and the trailers or the containers need to be put from the road to the train, and then go somewhere. And that is not that trivial. And if you have a automated hub-to-hub, you drive with an automated driver, or we drove with a manual driver to a hub. you just release your trailer, leave it there, and go away, or take another trailer, go back, and the automated truck automatically just couples the trailer and moves forward. I dare to say this is much more flexible and faster, and that's the reason I think the hub-to-hub will be more successful.
And if the railways are too heavily freighted, so there are no space for more trains, what do you think about alternatives?
Just for your understanding, if you need to break a train, this is not so much fun. The Knorr-Bremse is doing this. You're breaking steel on steel. So the in German called Mühwert. What is the English term for it? Mühwert. Mu value. The friction coefficient is very low, and the weight is pretty high. So you need to already start braking 2 kilometers from the station. So that is not really making it very flexible.
Of course. And what do you think about alternative methods like Hyperloop or something like?
I don't believe in Hyperloop. I don't believe this is sorry, this is an Elon Musk.
Yeah, not this in particular, but any other methods. I mean, in the future.
No, I believe the transportation, the principal transportation will stay. The ships will, of course, being electrified. They will be more efficient. Maybe you will get on certain areas the foils. This is what I saw just recently, a ship with a foil, and you will have the planes will stay. They will fly with hydrogen in the future. I believe more that the automation will increase heavily. Automation on trains, automation on trucks, and also automation on the logistic chain.
Thank you very much.
Okay. I guess we kept the time, huh? Thank you very much. It was fun.